Good afternoon, I guess. Happy to be the first welcome you all to this segment of Deco 18 here in lovely Columbus, Ohio on a beautiful spring day. I guess it still feels a lot like the dead of winter out there, so I guess we're doing okay being together in here. Again, my name is John Hann. I am the technical director at Henry F. Teichman of the newly formed E.W. Bowman division. So today I'm going to spend a little time just discussing basic firing techniques with annealing layers. I am mainly going to be covering glass as well as high temperature decoration, but a lot of what I'm going to talk about is going to apply to whether you're decorating ceramics or whether you're using lower temperature inks. I like to keep all this pretty informal, so as I'm going through this, if you've got any questions or want to talk about anything, just feel free to stop me. I guess we've got a little bit of extra time here today, so there's no rush. Okay, so I just wanted to kind of break down what I thought were kind of the top 10 factors, if you will, that are going to impact your firing quality. So, of course, at the top of the list really is knowing and understanding your decorating layer process capacity. And, of course, that is not defined by how fast the belt will move the product from one end to the other. Your set point curve, your belt speed, the loading plan. All right, we'll talk in a bit of detail about that. How you're going to load the layer, what the spacing is going to be, how you're going to group different types of products. All that comes into play with having a successful firing of your decoration. Of course, the material, the layer configuration itself, kind of the breakdown of heating and cooling zones and how many and what is really the best scenario to shoot for there. Your volatiles extraction, in most cases that's almost always a part of the process and needs to be controlled and understood. Tunnel drift, that's always a bit of a that's kind of a condition that's largely dependent on your factory and the way it kind of breathes, I guess. Tunnel drift's important both in an annealing layer process only or with decorating layers. That correct drift through the layer is going to help to maintain your temperatures. It's going to minimize your energy usage. It's going to allow you to successfully fire the layer. It's going to better control your volatiles exhaust. All of the above that comes into play. Along with that, again, factory conditions and then finally your basic burner setup and operation. Okay, so again, just trying to break down just the basic elements of understanding the layer process capacity. So all of this is going to come into play. All right, your glass entrance temperature, the rate, all right, at which you're going to preheat the glass to your firing temperature. Obviously, the soaking time. All right, how long do you need to maintain the temperature to get the fire that you're looking for, get the finish that you're looking for? Cooling rates through the annealing point. I've done a few of these at SGCD, and I do annealing seminars throughout the year. So if anybody's ever sat through one of these with me, specifically with the decorating folks, you've got to remember that if you're firing the glass up above the strain point, which is going to be the case anytime you're firing a ceramic decoration. You're firing it up above, about 950 degrees or so. Okay, you are now determining the final grade of annealing on that glass. Not just the decorating quality, but physical property of the glass as far as the annealing strength is concerned. So regardless of what the quality of the annealing was when you receive it, all right, once it's gone through your decorating layer, you're not responsible for that. So I don't know if everybody here, has the ability or has that as part of their process to grade annealing after you've fired your wear, but it is something that you need to be aware of, especially if you're doing, pressure items, anything for, beer industry or, anything that's going to be a pressure item specifically. You want to make sure you know where you are with your annealing grades. And then again, finally, cooling rate to your final exit temperature. So move on to this next slide here. So what I tried to do was really just kind of break down a typical decorating curve into 5 steps. So I kind of just outlined some of that. So when you're looking at trying to determine, does my leer have the capacity to decorate whatever item it is that you've received from a customer? Again, it's all about time, temperature, heating and cooling rates, soaking time. All right, so you've got to try and put all that together and determine, is my leer big enough to do what I need to do? Now, I know a lot of you, there's more flexibility there because you've got a lot of flexibility on what you're going to determine that your input is going to be. All right, if you're in a situation where you're, working with one of John's Weiger's struts machines, all right, you need to be able to handle to 400 bottles per minute. All right, it's coming at you. If you're in a scenario where you're doing more semi-automatic decorating, where you've got a little more control over, okay, what's my input going to be here? It's a little less critical. But you've got to determine what it is you want to achieve as far as pieces per minute. You need to determine how you're going to load the product on the belt, and then you need to figure out what does my belt speed need to be to accept this input that I'm trying to work towards. So after you've done that, you've established a belt speed. All right, now you can work through all these next steps because you know how fast your product's going to be moving through the leer, and I'm giving you some kind of target heating and cooling and soaking rates here to work towards. So this is broken down into basically light, medium, and heavyweight wear. You can drill down a little bit deeper into this, specifically when it comes to the annealing portion of it, because you need to be aware of what the glass thickness is also, specifically to make sure you're within the proper range to anneal the glass. But for getting the basic curve together, I've just broken this down into light, medium, and heavyweight wear. Okay, so I've given you some rule of thumb heat up rates. Okay, again from preheat to your decorating temperature, which that's going to vary a bit. We're going to assume that's going to be someplace, especially on the ceramic decoration. You're going to be between 1100, 1150, 1200 degrees. Usually that's typically about the max temperature that you're going to fire ceramic decoration at. You've got cooling rates for that. All right, I've got just an estimated soaking time in there of 15 minutes. And that again is going to vary a bit depending on, you know, whose paint you're using or what the specifications of that paint may be. There's a rate from decorating temperature, step 3, decorating temperature, back down your annealing point. Then from the annealing point to the strain point. And specifically there, you know, you can see the heavier the glass, normally the thicker the glass, so the slower the cooling rate needs to be between that annealing point and the strain point. That's where you're determining what the annealing rate is going to be in those 2 steps right there. And then the final recommended rates, cooling rates, their strain point to the final exit temperature are represented. So down there at the bottom, so once again, if you have some product, you have a job, you've got the glass information, you know how fast you want to try to produce it, you know how you're going to load it, you have come up with a belt speed. All right, if you just simply take the overall length of your tunnel, all right, of your controlled zones, not the entry table, not your packing table, the zones where you're controlling the temperature. If you just take that overall length, all right, and just figure out what your tunnel time is going to be based on the belt speed that you calculated, you're going to have a very good idea of whether or not you're going to be able to successfully process this particular job in your leer. Now, I'm good for any questions anybody has at the moment. I will be here tomorrow afternoon. If you want to talk about the details of that a little more, I can spend the whole morning really just the whole afternoon, just talking about that. But it's really not that complicated. You know what the length of your leer is. Basically, you break that down to inches. You know what your belt speed is going to be. It's inches per minute. Divided by the length of that tunnel. All right, and that will tell you what your tunnel time is going to be.
So this is based on a 12 zone.
Yeah, just a random example. Now we'll move a little bit further down the line, but this representation there has 12 zones. As far as to skip ahead a little bit, talking about what are the elements of an ideal configuration for a decorating layer. Typically, I don't like to design a decorating layer without at least 10 points of control. I know there's a bunch of you in here that are decorating a lot less than that. Some of you may have only 3 or 4 points of control where you can, manipulate the temperature in the tunnel. The problem there is that typically the decorating processes have very slow belt speeds. All right, and the belt's moving through there quite slowly. And you end up with big step changes in temperature. All right, you end up in, you only have, maybe you're in there for an hour and you only have 3 or 4 opportunities to change the set point or change the temperature to try and maintain these rates, these basic rates that I'm recommending here. So I don't like to design a decorating layer without at least 10 zones of control. Now, like I said, I know there's several of you out here that I have talked to for whatever reason, whatever issue you may be having, and we start talking about what's the configuration of the layer, and I'm like, well, we've got preheat zone, soak zone, and then we cool. And that's it. So it really doesn't give you much of an opportunity to try and correct whatever problem you may be having. Maybe it's firing too quickly, and you're getting, you're kind of getting the pinholes in your paint. It's overfiring. or maybe you're having some sort of a breakage issue, which could be related to, poor annealing. I don't know if anybody, really goes through any type of process like this. Again, this is more critical if you need to try and accept, a given input of glass. If you must be able to accept 200 pieces a minute or 300 pieces a minute, then you need to make sure you need to understand, what your temperature profile is going to be, where your set points are going to be, how these rates are going to work out. If you have flexibility where the decoration is not quite where I want it to be, I can just slow things down. Then this becomes a little less critical. Any questions about any of that? Like I said, I'm here tomorrow, so if you want to talk about any of this tomorrow, that is fine. Okay, so having an awareness of your loading plan. So, typically consistent and continuous loading is certainly preferred. If you end up with a lot of sporadic input, lots of space on the belt, it can create some issues with, again, maintaining, the specific firing curve that you're trying to maintain. Some leers are going to be better than that than others. All right. If you're running, a more modern recirculated leer that's got, it's stainless steel construction. There's no ceramics in there. There's no radiant zones. Those leers will deal with an on-off load much better than, say, if you're working with, an older oven that's radiant. Okay, no recirculation. It's got ceramic in it. They tend to be a pretty big heat sink, all right? They don't react to temperature changes quickly. So, you've got a constant load moving through there and everything's great. The leer empties out and then, you start and load another group of wear. The first half hour of the product gets overfired and you slump the stems on your wine glasses or whatever. So that's due to, the leer emptying out. Whatever heat source you're using, if it's elements or if it's gas-fired burners, they're going to fire up trying to maintain the temperature, and that can create some problems. So again, the loading plan definitely is a part of maintaining a consistent fire. Again, general rule of thumb is to try and minimize the spacing between the wear. It is ultimately the way you're going to get the full capacity out of the decorating leer that you're using. It will also make the operation more efficient, and again, it will improve the overall results. So plan to load products of similar weight and thickness. If you are, again, a shop that does a lot of different products, all at once, your daily run is, from 5 different customers, all right, and they're all dramatically different products, all right, one of those is going to be the piece that, determines this whole configuration, all right, and you need to either look at the pieces that you're going to run in behind it or around it, whatever you're going to mix in there, all right, you need to make sure that those items are going to live in this world, all right? Whatever you have determined is kind of the defining piece that's going to set up your temperature profile. So I know a lot of you all do that. You might have you might have growlers on there, and you may have, tumblers on there, and you have some dramatically different pieces all mixed in together. That happens a lot when we're on the phone with a customer trying to size up a lyre, and I say, okay, tell me what your product is and how fast you're going to run it. Well, I don't, I might have 6 or 7 different things on that belt all at the same time. That becomes a bit of a challenge to try to set the lyre. So you've got to choose the piece that's going to, define what your setup's going to be, and then, don't put something on there that's, much heavier, all right? When you're running it at, a 70-minute tunnel time, don't put something in there that needs 130-minute tunnel time. That's not gonna work.
So, John, is there a rule between lightweight, heavyweight, glass ceramics when you're loading multiple products? What would the preference be? Would you start with light?
To mix glass and ceramic?
Yeah.
Yeah, well, again, so typically, as far as the vessel's concerned, ceramic is fairly forgiving, all right? Your setup is going to be more tuned specifically towards firing the decoration. You don't have nearly, the expansion that you have to deal with on soda lime glass that you deal with a piece of ceramic. So, in that case, I would say, if you've got glass on the lyre and the speed of the belt is enough time for your ceramic to, fire out the decoration properly, then you can probably run that right in with your glass without a problem, other than, being aware that, you've got to be aware of what your firing capacity on your lyre is. So if you fill it up with a bunch of ceramics, you may find, your burner outputs are, standing at their maximum, and you're not able to achieve the set point in the zone that you're looking for, because you're just, increasing the mass that's going through there. But again, the ceramics are a lot more forgiving. There's no, obviously there's no annealing to be concerned about with the ceramics. Your whole setup is more based on, getting your decoration fired out.
In terms of the weight, what would you prefer? Like, is it better to do lighter made and heavy, or heavy made and light? Like, what sequence should the weight of the glass, follow in the lyre? The weight, you mentioned different weights, right?
Yes.
So is there a sequence? Is it a better way to do the sequence-wise, or is it?
Again, if you're mixing, you're going to probably want to run the heavyweight stuff. That's going to set, that's most likely going to set the speed of the belt. So you run your heavyweight stuff in, but then again, you run the risk of, if you put something in there that's dramatically lighter, you may have some deformation, you may have some chain marking, you may overfire the decoration on the glass. It is definitely when you're doing that, it's definitely a trial and error process when you're mixing stuff on the same belt. I know a lot of you do.
Do you not find that if you start off with an empty lyre and you start off with a heavy item, that you can have some underfiring at the beginning?
So here, this more goes back to what is it that you're working with.
Because I've always it's always worked better for me to start off with a lighter stuff. Then to go to heavy.
If you're going to mix wear, all right, you have to determine what's going to set your belt speed. All right, what are you choosing to set the belt speed with? So the majority of what you're running through there is a heavy piece. That's what's going to have to set the belt speed. If you choose to run, if you choose the majority of what you're running to be a lightweight piece, and it's going to have to run at a higher belt speed, you're not going to be able to mix a heavy one.
Yeah, but if you are going to slow your belt speed down to a slower belt speed for the heavy item, would you still not want to put the lighter stuff on first and then put the heavier on? No.
Like I said, that goes more into what are you working with. And I know, I don't know if you guys, I don't think you have any type of non-recirculated radiant heated lyres in your operation, do you? So if you're working with a recirculated leer, then, you know, you shouldn't be overfiling glass. You know, if you've got a leer that's, you know, stainless construction, recirculated, you know, controls correct, the initial product that goes through there certainly shouldn't be overfiling. Like I said, that typically happens when you're dealing with something that's a bit of an uncontrolled heat sink. You've got an old ceramic radiant heated leer that you know, contains a lot of heat. The first wear that hits it typically ends up getting overfired.
Yeah, John, ceramic, I'm not talking about deco, but
Yeah.
regular fire rating. For roller earth, we might put dummy loads between.
Yeah.
Is that something that's commonly done or not?
Well, I guess I'll ask everybody out here. You could do that, all right? You could, you know, try and maintain a consistent load. You know, you could just put blanks on it. I'm guessing most people don't do that. You know, I mean, they only have, you know, specific amount of glass from their customer that they're gonna decorate, so they're not gonna use that. You know, it's kind of a, as you say, a dummy load to try and keep the load consistent. So yeah, I mean, this is, like I said, this is always a challenge. You know, so again, if you're you're a huge bottle manufacturer that's just going Rolling Rock or Corona or, you know, large volumes of wine bottles, it's, you know, this really doesn't even come into play. You know, you've got a high-speed decorating machine that's loading the wear constantly, consistently at a given speed, and it actually makes the job of sizing and determining the setup for the leer much simpler than what a lot of you do with you know, mixing various products on there simultaneously. And it does become an issue. I mean, I've had many conversations where I've told somebody, listen, you've got to give me, you know, you've got to create some sort of production scenario for me so we can size the leer. You know, you have to have something to determine the size of the leer. Again, you know, decorating material, I'm really not going to talk a whole lot about decorating material. You know, it's pretty straightforward. I mean, you know, you need to know what the curing time is, what the curing temperature is of the material that you're working with. You know, have the data sheets from your customer, know what it is. You know, I guess as far as just from a practical, you know, recommendation from just experience, you know, I have seen, you know, decorating issues arise where, you know, there's, you know, the batch of the material changes in the middle of a run and, you know, has a slightly different configuration that can create some issues. You know, again, anybody that's doing anything that's a pressure item, so, you know, the Owens, Illinois, and the Ardagh Glassa, and any of those folks that are decorating beer bottles, all right, every bottle after it's decorated, you know, the annealing's not only checked, but it's pressure tested. All right, it's pressure tested again. So, you know, high temperature ceramic paint is basically, you know, it's a glass frit. It bonds with the surface of the container. If there's too much of a difference between the coefficient of expansion between the paint and the glass, all right, you can create surface tension that will lower the pressure breaking point of the container. Like I said, all the big folks are pressure testing everything that they decorate. And I have definitely seen that where all of a sudden the pressure numbers drop off and they're like, well, what's wrong with this firing curve? Well, the decoration's good, the annealing's good, you know, the exit temperatures are where they need to be, there's nothing wrong with it. Well, why are we losing pressure? Because you've got an issue with the expansion rates, the relationship between the expansion rates of the paint and the glass. So, I've already talked a little bit about, the importance of, whether or not your job's going to be easy or difficult, as far as, having a good decorating result. And again, the layer configuration is definitely a big part of that. As I mentioned, I don't like to have a decorating there without at least 10 points of control. Of course, it's preferred to have, recirculated zones, for a multitude of reasons, temperature uniformity probably being the greatest. You need to have a means to exhaust your volatiles. If you don't get the volatiles out of the leer, typically one of two things that are going to occur. It's going to collect inside the leer. You're going to end up with, the drips and all that goes along with that, or you're going to end up with, some version of bloom on the wear, where you're exiting and you've got a gray deposit on the glass that typically wipes off. That's usually coming from one of two places. Either the volatiles are laying in there, or your burner setups are bad. You've got a bunch of unburned products of combustion floating around. And then, of course, having adequate flow of the exhaust and the correct exhaust ductwork. Now, I've included a little. It's a little hard to see here, and this is more of just a recommendation. But with your exhaust stack, I know a lot of folks will use a cap over the top of their exhaust stack. I prefer and recommend that you use a no-loss stack cover. All right, so this is not a cap over the top. Basically, this is simply a sleeve that sleeves down over, all right, your stack as it penetrates the roof of your facility. It's basically a sleeve that's about an inch in diameter greater than the main stack, and the height is about 4 times the diameter of your stack. And what that does is it keeps the moisture out of your stack without restricting any of the air.
What's it called, Joe?
It's a no-loss stack cover. So basically, the principle behind this is you're trying to keep moisture out of your stack from weather, from rain. And the only time that you're going to get rain down that stack is when it literally is falling straight vertical down the stack. Otherwise, if it's falling at any part of an angle, it's going to come down the side, around the bottom, or it's going to hit the outside bottom. That's a pretty easy change to make, actually. I don't know what you all are working with as far as exhausting. In some cases it's fine just with the pressure in the leer, and you get plenty of flow out of the stack. Depending on how much ductwork you have, sometimes you need to have a blower in line to get the material out of there. Go ahead and move on to this. You just need to be careful that you don't end up overdrafting the leer and literally, we'll say, pulling your process heat out of there. All right, which again creates a temperature control problem, and it creates an efficiency problem. So, again, regardless of really whose leer it is, or you're going to have some exhaust in some place in the front, in the first zone, in the first couple zones. And again, the setup of these is basically trial and error and what ends up working best for your specific situation. But you want just enough to get the volatiles out, all right, and keep it from pushing out into the factory. I do recommend against directly connecting your ductwork to your actual exhaust on your leer. All right, leave yourself some space around there. then if you do end up, having a little too much draw, you'll pull excess air from the plant and everything's not coming out of your leader. All right, so don't direct connect it to your leader's exhaust ducts. Again, depending on where you're at, there's different requirements for how you deal with this, but ultimately, you want to be aware of, if you've got anything building up inside that stack. Probably everybody in here at one time or another has seen one of these catch fire if they're not maintained. So keeping it moving and getting it out before it has a chance to cool off is generally the best way to do that, and that'll minimize how much of it builds up on the surfaces.
On the Bowman mirrors, do you have an adjustable? Is your CFM adjustable?
So the exhaust ducts are the volatiles exhaust ducts are adjustable. They're manual. Okay, so it's not an automatic adjustment. It's manual. So you basically start off with everything closed. This is the way I do it. You start off with everything closed. You start running your product. You see, where your volatiles are moving, and you basically get the damper settings where you're removing it, all right, but you're not, creating, an increase in burner output or a significant increase in burner output in the rest of the leader. So it's somewhat of a trial and error process to get them set to where, they're drawing the volatiles out, but not drawing out too much.
Depending on the product that you're firing as well, and how much paint you have on it.
All the above. All the above, yes. Yes.
Well, how do I keep sensitive colors that are sensitive to reduction from being affected by those volatiles?
Well, again, it is it's kind of a job by job process to find the right amount of exhaust, to accomplish all of that. Questions on that? So, tunnel drift, and this all kind of plays together. So you like to see, you always want to, in general, you always want to see the flow in your factory moving from the discharge end of your decorating leer to the charge end. All right, you would rather not see the air moving in the opposite direction. All right, having counter drift, helps you to maintain the annealing temperature profile at the back end of the leer. All right, it minimizes the output of your high temperature zones where you're soaking your decoration, and it also keeps those volatiles forward. All right, and moving out of your exhaust ducts and your collection hoods at the front of the charge end of the leer. So just in general, you need to try and be aware of uncontrolled airflow, from open doors, from fans, from ventilators, from ducts, whatever may be in the area. If you've got stuff blowing into the front of your decorating layer, that is not what I would consider the ideal situation. Again, in a decorating operation, typically, if they're in a glass plant, they're offline, and so it's a little easier to control this in a decorating operation than it is in a bottle plant. Okay, and then finally, just knowing that the setup on your burners are of course correct. Just really some common sense recommendations here. You know, following the manufacturer's instructions for proper setup. Make sure you've got a proper combustion ratio. You know, specifically with decorating, you don't want to be running with a very rich burner setup. You know, that's going to affect the quality of your decoration in several ways. You know, if you're working with burners that have, you know, combustion air, you know, those filters need to be cleaned regularly. You know, if you've got blowers with squirrel cage fans, they need to be cleaned. Maybe some of you are working with, you know, atmospheric burners, or maybe even electric elements where, you know, it's literally no adjustment involved in that. But, you know, really out of all this, I mean, the burner setup is important, but, you know, I kind of put it last because, you know, all of those other elements really, in my opinion, have more of an impact on, you know, than just, you know, simply making sure your burners are on and operating. Okay, well, that's about what I wanted to cover with you. If there's any more questions, that's fine.
Yeah, in general, I agree with the comments on the ceramic items, but I think it's more important to consider the sidewall and base thickness of the ceramic piece rather than the weight. You'll find that most ceramic mugs are 400 to 600 grams. And I've seen people try to fire a diner mug with stems and shear the bottom of the diner mug to clear out.
Yeah.
So that's really more important than the actual overall weight.
Yeah, like I said, I mean, you know, of course, it's, you know, very different. As I said, you know, there's a lot less concern with that type of breakage with ceramic than there is with glass. But I agree, and it is the same with the glass also. The thickness comes into play. Again, when we're sizing and decorating there, I'm asking you what the maximum thickness on your pieces are going to be. I find because there's such a variety with the decorators, it's a little easier to break it up into a weight category rather than bottom thickness. A lot of times that's a difficult piece of information to get from a customer, is what is the maximum thickness on the piece. Wherever your glass is coming from, a lot of times they won't tell you that. There's usually a specification, but you know, is that what it actually ran at? Who knows? I mean, you've almost got to cut the piece and measure the thickness sometimes to know what it is. But yeah, I agree.
Yeah, generally, I think it's a good way to look at it is if look at your ounce capacity as compared to the overall weight of the mug. And if you find that you know, you got a 10 or 11 ounce mug that weighs over a pound,
Yeah.
and you've got
You got a lot.
eyeballs and things.
Yes, that's correct. Yes.
John, do you guys do any kind of calculations on pressure in the building and then the height of the stack?
If so, you know, if it becomes necessary, we have done that in the past. Normally that is something that is the responsibility of the customer to provide us with that information. But yes, there's no question that will affect how the mirror is going to ultimately exhaust, and you know, whether or not you're going to need some type of inline blower, or you know, there's a lot of elements there. That is something, a piece of information we would normally ask for.